Back to two gauges because I want to talk about the pressure limiting compensator. The pressure limiting compensator on the pump is what's going to control our maximum pressure when we stall a function. So I'm going to take that side shift right to the far end, and we'll see when we stall it what we get for maximum system pressure on the right hand gauge here. Get about 3375. That's our maximum system pressure being supplied to the valve, and that is therefore the setting of the pressure limiting compensator on the pump, or the pressure limiting or pressure limiter, or the high pressure cutoff setting of the pump. So it's acting like a main relief in that it's limiting maximum system pressure about maybe 40-50 psi or something lower on the standby, or sorry, on the load sense signal. I'm not sure why there's a difference there at stall. These gauges really should be coming up to the same pressure, because once your implement has reached the end of the travel and you're trying to send oil into a dead-ended cylinder, there's no flow across the orifice effect of the DCV spool anymore. If there's no flow across an orifice, there's no pressure drop across it. So the pressures really should build up the same. That may be an indication that a little bit of oil is flowing, and it may be because there's some leakage in that cylinder or inside the directional control valve. But I wouldn't necessarily troubleshoot based on those numbers unless there was a symptom from the operator. But so we're seeing about 3375 as our maximum pressure setting. Again, it's like a main relief, but there should have been something you really would have drastically noticed different from this machine versus a machine that's got a main relief. Listen to the engine when we stall this function. So the engine's barely working. We're at very high pressure, but because the pump is fully de-stroking with the pressure limiting compensator, I don't hear the engine under much load at all. In contrast, if I give some flow and pressure, and now you hear the engine working. So again, with a variable displacement pump and a pressure limiting compensator, that's something for an operator to get used to. When there's pressure and flow, those are the two values that you multiply together to get hydraulic horsepower. So if something's moving under pressure, then you hear the engine under load as the pump pushes oil against pressure. But once you come up against the pressure limiting compensator, the pump fully de-strokes, so there's pressure, but there's really negligible flow. So the horsepower load's nearly zero, so you don't hear much load, you don't hear much of a pitch change of the engine. And again, some operators may perceive that as a lack of power. They stall a function, they don't hear the engine being lugged down by the pump, and they think that's abnormal, when really that's normal. And that way, if an operator has a function stalled and no work's getting done anyways, we're not wasting a bunch of fuel pumping oil over a relief valve. If we want to adjust that pressure limiting compensator setting, we take this yellow cap off and make a very similar adjustment to what we did to the load sense screw. Take the cap off, unlock the lock nut, turn the adjuster. That's going to control our maximum system pressure. So the cap's off there, and I'm just going to turn that screw. I'm going to turn this one out. And we'll just back this screw out about, I'll take it back out about half a turn. We'll see what that does to our maximum system pressure. We'll just loosen that setting. And I'll tighten the lock nut and put the cap back on. So cap's going back on. Worked better with my left hand than I would have ever thought. Just snug that cap back on there, and we'll go recheck our pressure limiting compensator setting, our maximum pressure. So a half turn out brought our maximum system pressure down to about 28, 25, approximately PSI. So I'm just double checking those specs before I set these back on this machine. Looking in the G900 service manual. So for the pressure limiting compensator, they call that adjustment the pressure compensated set pressure. Well, it's kind of cryptic, but 3,250 PSI, or 22 megapascals, 224 bar, if you prefer. And then differential pressure setting for standby, they say it's 350, and they're not giving the plus or minuses on this spec page, but in the actual procedures, they do give you the plus or minus, and again, there's quite a range for the differential pressure setting. And here they just provide a picture of that Rexroth load sensing pressure limiting compensated pump, and they show us where we're going for the adjustments, etc. So we were taking the cap off the load sense control and adjusting this stem in the load sense control, and then the cap and the adjustment for the pressure limiting compensator, the big spring. And then, as I mentioned before, there is a solenoid to unload the pumps during engine cranking. This solenoid gets full 24 volts during engine cranking, and a plunger pushes out here and kicks the load sense spool over to allow the pump to de-stroke without having to build up that standby pressure of engine cranking. Once you've let go of the key from the cranking position, then the solenoid is de-energized and you go back to operating on load sense signal pressure and system pressure.